Good afternoon, everyone. I'm Professor Ksenia Chmutina, and I'm the director of the Institute of Advanced Studies. Welcome to today's lunchtime seminar. It's our absolute pleasure to host Dr. Luisa Fernanda Chaparro as our Open Program Fellow today. Welcome, Luisa. Thank you for joining us. And as always at the IAS, we are going to talk about the exciting things. So today we're going to talk about digital twins for urban mobility and urban planning. We have been talking actually about urban planning quite a lot in recent weeks. So it's great to continue that conversation. And I hope those of you in the room, you've been to previous talks, so it's very exciting to see this topic really coming up over and over again. A couple of housekeeping rules. So for those of you in the room, there will be time for Q&A. Kieran, Lauren, Connor will be managing that, and of course there will be time for discussion during the lunch. And for those of you joining online, please post your questions to the Q&A section, and we will be monitoring those. The presentation will be recorded and it will be released on our YouTube channel and also later on as a podcast. For those of you attending, you will get the link to that. But the discussion part of the session will not be recorded. With that, I would like to pass over to Martin Sikora, who is hosting Luisa today. Martin, over to you, please.
Thank you so much, Ksenia. It's an absolute pleasure to welcome Dr. Luisa Fernanda Chaparro today, who is a research professor with the Science Department, School of Engineering and Sciences at TEC de Monterrey in Mexico. Her main research interests include smart mobility, big data applications, and actually she has a strong computation modeling and phenomenology analysis background in high energy physics. Dr. Chaparro is also a member of the OWSD, Organization for Women in Science for the Developing World, the UNESCO Colombia chapter. She is also a member of the National System of Researchers in Mexico and Colombia, and it's my pleasure to be able to host you as a guest with us this week. And over to you.
Thank you, Martin. Thank you, everybody. Thank you for the invitation. Well, today we talk to you a work that we are done with the Sustainable Energy Research Group at Tecnológico de Monterrey, and it's called MAITEC. That is basically I talk about a digital twin that we use for a sustainable urban mobility. Okay, first of all, where is this MAITEC thing? Think about the possibility to have a city to respond about the problematics that maybe have. For example, what happens if there is a increment of traffic, or what happened with the raining, or when a hurricane, and so on. And the idea is like MAITEC is not only a platform to see the things or the data that happen in the city. It's all the models that are behind this visualization in order to understand or in order to take decisions based on data driven. Yeah. We base our digital twin in our hometown, that is Monterrey. There is a city localized in Mexico, in the northeastern of Mexico. The idea is like we start to see which kind of models try to solve different or to approach to different problems, like, for example, traffic, air quality, amount of emissions, and try to create some strategies for decarbonization. Okay. These are these four main objectives of this digital twin. And it's basically, first, optimize mobility. In order to do that, we need to understand where is the people, how they move it, how the kind of transportation use, the places they are visit. After that, we also we like to enhance their quality. In order to do that, we need to estimate the amount of emissions that we produce using this carbon transportation modes. Also promote the energy efficiency, how we can reduce the emissions, how we can start to change of the use or the behaviors in the people in order to improve, yeah, or to reduce, to decarbonize, and also offer this like a playground to the decision makers in order to say what if scenarios to be what happened in the city based on data previous to take action in the city. Okay. Basically, we have some, the idea is like to obtain some mobility metrics, see what is the health impact, I mean, the air quality, the consumption of energy, what is the cost value of these kind of things, and also take this information to policymakers to take decision based on data driving. Our digital twin have a lot of layers, and I show you this. The first one is location and demographics. The core of MAITEC is based on geodata. After that, we have something about infrastructure for mobility. We need to know what is the amount of vehicles and what kind of fuels use that vehicles, because it's different. We have diesel or is electric one. Also, we need to know what happened with the mobility, what happened with the traffic that we have in the city. Calculate emissions, include some information about meteorology, and see what happened with these emissions, how move these emissions, if it remain in some place in the city, or how they move. And also we want to see what is the impact in the city of these kind of things, especially in health. What happened with flooding, what happened with electrical infrastructure, and what happened with the bio or the traffic infrastructure. The idea is like, this is like a cycle, yeah? We have the information, the data, but also we run models behind them in order to obtain layers. The layers are correlated between them. And the idea is like, we also have information, visualize, take some strategies, and after that, run again in order to see what changed in the city when we apply this kind of strategies. For example, what happens if we develop or we put some barriers to reduce the pollution? If we create more parks, for example, if we create design different kind of ways for bikes or for walk, yeah. We also try to use different kind of data, different than a traditional way, to understand what is the behavior of the people, yeah, and include it in all of those. Today, I will talk about all these layers, of course, but I focus on these three because are the three that I work more. Okay, this is basically like a view of our digital twin. This is the Campus Monterrey, one of the parts of the Campus Monterrey, of Tecnológica Monterrey. That is being done by the LiDAR scans. And the idea, the first one, as I told you previously, is the geodata. How are the buildings, the roads, and so on. And we use some GPS coming from the cell phones. Every time that you open, for example, WhatsApp or Uber or so on, and you give access to your GPS position, that GPS position, we record it. And we take it, obviously anonymized, and we see how you move, where you are at different type of the day, and also different days in the week, yeah? We have 3 months of data for the whole Mexican Republic. And the idea is try to understand where is the people. Traditionally, these kind of things are made using a survey, but the surveys are not cost effectively or harder to take the data. And also it's static data, static information. You only can take the survey once or maybe twice per year. This is a dynamic way to obtain the data. Yeah. How we do that? Basically, we study this the region that is our city. We capture this cell phone geoposition. Obviously, as I told you previously, anonymize is important to have this. We trade information. We use these ping points that basically give the GPS in order to understand which kinds of those are a trip and which are a stop, in order to obtain a new database that is basically our origin destination matrices. Yeah. With this origin destination matrices, we made a validation, with kind of data, with the national census. Yeah, we have this, and we can study different kind of things. For example, what is the use of the roads? Yeah, if we have the origin and destination, we can to improve and see where is the common trip that the people done or the people use. Where is the attractive travel points? Where is the destination, the principal destinations? And for example, we looked at the government buildings and also universities, schools are privileged to the other kind of buildings. And also we try to understand the behavior of the people in the travel and distance metrics. Yeah, and for example, we know that the common days to travel are Monday to Friday from work hours and so on, and we can see that through this GPS data. Okay. After that, we take this like an input for the infrastructure of the mobility. The idea is like, if we know where the people is and where the people come from one place to another one, we can start to see where is the occupation of the roads. Yeah. After that, also we need to know where is the fleet, how is composite. In the case of the metropolitan zone of Monterrey, we have this information, and if we know now, we need to know how the people use this fleet. I mean, how the mode of transportation we are using to go from one place to another one. In order to do that, this is a lot of maths. I don't want to be boring you with this maths, but it's basically we try to put some probability in the different transportation modes that we have at the city. Yeah, we basically, okay, Monterrey. It's need to that I say that Monterrey is a desertic zone in Mexico that the weather is heat the most of the time of the year. That means that the people want, or basically privilege, use car than walk. Yeah, by obviously reasons. But the idea is like we use, okay, we maybe walk in the winter season. We use the car, we use the bus, the system bus. We have a metro. And the idea is like we want to look into a pilot zone. The pilot zone is the Tec de Monterrey zone and its neighbors. And the idea is like to put a different probabilistic weight for each of these transport mode and see what happened with this in the city. This becomes an input for a traffic simulation. Yeah, the idea is like we use this into a Sumo. Sumo is a platform in order to estimate how the ways, yeah, how the streets are used in different times of the day. What happened if a traffic light is off or on, for example, and also that we see what is the congestion of these streets. With this information, we use it in order to estimate the emissions. Yeah? We are interested in the greenhouse emissions, and the idea is you need first estimate if you want decrease it. Yeah, if you want to take actions. That means that we, for example, we are looking into the CO and O, and also if we have the information hour per hour, we can estimate this again hour per hour. That's the idea. We also include information about meteorology. Yeah, we use some models that work on CFD in order to do that. And the idea is to see what happened with the wind and how the wind affects the emissions. Yeah, how the emissions move, if the emissions move or remain into some place in the city. And what this is important, because if we know where the concentration of the emission is, we can also include another stage that is the health impact. Because it's different if we have closer a school with a high level of pollution, and if we have I don't know, empty space. Yeah, the risk is different, and we want to estimate the risk. But also, we study what happened with the flood risk. As I told you previously, Monterrey is a desert zone, but from time to time, I'm like 10 a decade, yeah, we have hurricanes. And these hurricanes basically flooding all the city. And we have big impact in some infrastructure, especially in the traffic infrastructure, in gas natural infrastructure, and also in electrical infrastructure. Basically, we have some days that all the things are down, yeah? And in order to do that, we use a model to create a scenario. This is, for example, like 100 years scenario, the worst scenario that we can have in the city. And to do that, the idea is like try to understand, or if we have the information of the natural gas and electric infrastructure, see if we overlap this information, see if this kind of flood is a risk for this infrastructure. And in order to do that, we have two things. The first is the perception of the risk. Yeah, I told that it's perception because we are based on tweets information. Yeah, we basically with that we collect the data from tweets that have information, the name of the hurricane. The last one, for example, was Alberto's hurricane. And they talking about lights down, some traffic issues, some electrical issues, and so on, fires, so on. Yeah. After that, we process the data. We include some sentiment analysis in order to understand or to put a number to try to quantify this perception if we have the risk low or high. Yeah, and also to classify, because it's different if we have a damage in the vial infrastructure than in the electrical infrastructure. Also, we made this geospatial analysis, and we validate the results. And we have this, for example, the heat map that you see behind is the vulnerability map. And this is done using government information, yeah, like surveys. They go house by house and ask if you have energy, how many times you use it, how many consumption you have, and so on. And the other ones, the blue ones, are our data from Twitter. Yeah, from those days that we have this hurricane at Monterrey. And we kind of see some overlapping between one of those. And the idea is also use this in order to create a public policy to prevent some things at the future. Yeah. And I wanted you explore by yourself our digital twin. Because as I told you previously, is not the MAITEC. This is our visualization, but remember that our digital twin is not only visualization, it's all the models behind. As you see, this is Monterrey. For example, you see, I want to show you the prisma. As you see, we can put these kind of icons in order to inform us. For example, this is a problem in the electricity, yeah, but this is fire, yeah, and this is a closed road, and maybe here this is a floating, yeah. And the idea is try to play with all these layers to understand what happened at the city. And obviously the idea behind this is use this to take decisions in data. That's the thing that I want to share today to you guys. Thank you so much.